Situated in the north of Namibia at the farm Sargberg near Otavi, you'll find the most technologically advanced plant of its kind in Africa. Ohorongo Cement Pty Limited was established by the Schwenk family from Germany, which has successfully produced cement over the last 160 years. The word Ohorongo means kudu in the Otjozondjupa language. An amount in excess of 2.5 billion Namibian dollars was invested in this plant, and Ohorongo Pty Limited is currently the only cement-producing company in Namibia. The cement plant was constructed in a record period of 22 months and is built according to the best available and most modern technology. This makes the Ohorongo cement plant the most technologically advanced plant of its kind in Africa, as it has been designed for the highest levels of output with the least impact on the environment and surroundings. Using the best technology available allows for a 30% reduction in electrical power consumption as compared to traditional cement plants. And this system also saves up to 220 cubic meters of water per day. Production started at the beginning of 2011. The availability of most of the raw materials in the Ohorongo quarry ensures sustained production for more than 300 years. All additional raw materials required to produce the cement are sourced within Namibia, making Ohorongo one of the few production facilities that add 100% value to the country. On top of that, it makes Ohorongo cement a truly Namibian product. But let's have a closer look at how cement is made. This is a schematic presentation of the whole cement manufacturing process. Raw materials such as limestone, shale and marl is collected at the quarry and transported to the crusher. From here it is conveyed to the mixing bed, where the gravel is mixed to a homogeneous material. Additives such as quartz, sand and iron are added and then sent to the raw mill, where it is dried and ground into a fine powder. Now the raw meal is transferred to the preheater. Here the material is preheated and then conveyed to the rotary kiln, where it is burnt to clinker. The clinker is cooled down and stored in the clinker silo. Secondary additives such as gypsum is added and then conveyed to the cement mills, where it is finally ground into cement. The cement powder is stored in the cement silos. From here, the final stage is the bagging of the cement. The most important raw materials for the production of cement are limestone, shale and marl, which are available in large quantities in the quarries of Ohorongo cement. The other ingredients such as iron ore are supplied from the Ohorongo mine, and gypsum is obtained from a mine close to Swakopmund. One could say that the cement making process literally starts with a bang. Holes are drilled to a certain depth, and then a sausage-shaped cartridge is lowered to the bottom with a detonating cord. A few more cartridges are added. Highly trained, experienced staff are used for this task. The hole is then filled with free-flowing ammonium nitrate, also known as Anfex, to a depth of about 1.5 meters. A detonator is now added to the cartridge and is lowered into the hole. The hole is then finally filled up with gravel. All cords on the surface are connected and now ready for blasting. For safety purposes, the blasting area is evacuated. Ohorongo cement uses a fuse with a 4-minute delay to set off the blast. The limestone, shale and marl rubble is loaded onto huge trucks with a loading capacity of 60 tons each. These raw ingredients are transported in specified ratios to the crusher, where they are ground to the consistency of rough gravel. The crusher can handle 600 tons of raw materials per hour. The crushed limestone, shale and marl are conveyed to the mixing bed, where the gravel is mixed to a homogeneous material. The homogenization store has a radius of 81 meters and a height of 28 meters, and has a blending bed which can handle 25,000 tons of mixed materials. The chemical composition of the material is carefully monitored to ensure that it contains the correct proportions of limestone, shale and marl. A combination of materials is added to the mixture if the proportions differ from those specified by the quality department. Essential additives such as quartz and iron ore are added to the homogenized limestone, shale and marl material, and this mixture is then conveyed to the raw mill, where it is ground to a powder with the consistency of fine flour. Simultaneously, the mixture is dried by means of the redundant heat generated from the firing process. The plant uses roller mills instead of the traditional ball mills. The roller mills save about 30% on the total electrical power consumption compared to traditional ball mills. The mixture or fine powder is tested once again to ensure that the chemical composition is correct in terms of the quality directives. Once the raw material has passed the tests in the laboratory, it is conveyed to the preheater. The preheater is 109 meters high, one of the highest structures in Namibia, and the raw meal silo has a capacity to store 7,000 tons of raw mixed powder. The raw meal is preheated by utilizing the excess heat from the rotary kiln. The actual burning process of transforming raw meal into clinker is shortened significantly, saving time and energy. Once the raw material has been processed in the preheater, it enters the 54 meters long rotary kiln, where the material is burned to clinker at temperatures of 1450 degrees Celsius. The rotary kiln can handle 2,100 tons of clinker per day. The clinker is now cooled down by using a method of air quenching instead of the traditional water conditioning. This method saves up to 220 cubic meters of water per day. After the cooling process, the clinker is stored in a clinker silo with a capacity of 55,000 tons. The clinker is dosed with an appropriate quantity of gypsum, and in specific cases, if required, with high-grade limestone. Finally, the mixture is milled to cement by using 2 cement mills. Each cement mill can handle 65 tons per hour. Ohorongo cement plant manufactures 3 different kinds of cement, which are stored in 3 different cement silos, each with a capacity of 7,500 tons. Most of the cement produced at Ohorongo is dispatched and delivered in 50 kilogram cement bags, bulk bags, as well as cement tankers. Robotic machines count and stack the 50 kilogram bags on a pallet in batches of 40 bags per pallet. Thereafter, it is shrink-wrapped for additional handling and protection. The state-of-the-art packaging plant can handle 4,400 bags per hour. However, bulk cement is available in loose form and is transported via road and rail. Every step of the entire production process at Ohorongo cement plant from the quarry to dispatch, is continuously monitored and controlled by highly qualified personnel in the control room. Wherever and whenever required, any part of the cement-making process is adjusted immediately. This is to ensure that the highest quality standards are met and to ensure absolute customer satisfaction. All cement produced at Ohorongo is SABS approved according to SANS 50197-1. Besides the control room, there is also an ultra-modern, fully equipped chemical and concrete laboratory. Samples taken during the cement manufacturing process are constantly tested. The laboratory consists of 11 sampling stations, which handle 144 samples per day, 7 days a week. Each cement type produced at Ohorongo is tested for compressive strength, water demand, fineness, and expansion. We have now witnessed the complete cement manufacturing process. But why is the Ohorongo cement plant so unique? Cement produced by Ohorongo is of the highest international standards and is a 100% Namibian manufactured product. In other words, all raw ingredients come from within Namibia. Nothing is imported. Ohorongo is equipped with one of the most sophisticated filtering systems in the world. This enables the cement manufacturing plant to keep the levels of air pollution to an absolute minimum. The Ohorongo cement plant is also unique in a sense that it can replace coal up to 80% with alternative fuels, such as wood chips. The Energy for Future project was initiated, and local farmers, as well as Ohorongo cement plant, will benefit from it. More than 120 million Namibian dollars were invested in debushing equipment to harvest invader bush in the Otavi region. The invader bush is downsized to wood chips, which in turn is used to fuel the rotary kiln. This is the Ohorongo cement plant, the most modern plant in Africa, which can produce in excess of 700,000 tons of cement per annum and create more than 300 direct job opportunities and an estimate of 2,100 job opportunities via downstream activities and support services. Ohorongo Cement, secure supply for our future. Build forward.